Good evening, all. And how are we doing this evening? It's good to see the regular faces. Cold! Cold, really? Fair dinkum. Hang on a second. Oh, you're down south. Yes. All of you southerners are suffering, hey? It's getting a bit chilly, starting to get into the guts of autumn. Are we technically in winter yet? No, that's June, July, August, isn't it? Yeah, so sounds pretty awful. What are we rocking? Actually, that's a great question. So up here on the sunny coast right now, looking at my weather app on my phone, it says we are currently 22, feels like 24. Got to 26 today. So there you go. Freezing. Oh, Gombos. Thank you for the subscription, mate. That is very kind of you. Very, very kind indeed. Cheers to you. So, as we all know, hacking/deving without tea is very uncivilized. So tonight's brew again for me is the ever reliable green Gaiokuro from D2, T2, which goes spectacularly well with the odd slice of 90% Lindt dark chocolate. So let's start the evening off with a bite. I hope you can join me. I hope you have your respective beverages and poisons. Is that some sort of flash T2 mug? Actually, no, it's not. This little flask/thermos that I have here is from a brand called Yeti, and it was bought by Sean actually as a birthday present to little old me last year, and I use this every day. It's a really good thermos. So yeah, big thumbs up from me. Would definitely buy another one of these. So, oh really? It froze. Just mate, let me welcome you again, Gombos. Thanks for joining, and thank you so much for the tier 1 subscription. I really appreciate it, and I'm glad you're part of the show, mate. So cheers to you. Yum. Okay. So, hey Towentum, sorry. My pleasure. I hope you guys are getting a kick out of this as well. So far the feedback has been pretty good. I'm hoping that there's going to be more positive feedback as things go, as we start to cover more and more of the internals, and we end up filling out the guts of what Meterpreter is. So, and along the way, you know, the C# and .nettiness of what we're doing hopefully will empower you guys to go off and build your own stuff. Is it just me, or is the color saturation a little out? It is a little out, and I think it's because I'm wearing a white shirt. But it won't matter in a sec because I'm going to flip over to VMware anyway. And so that's all that matters. Just put me over to the top left, that side. That side. Put me over that side. Don't worry about me. I'm just, every now and then I get hand wavy, which is why I like to sort of be on screen. Plus I think there's a better human element to having my face on screen, even though it's ugly. Yeah, well, you know, there's a possibility of that too. I'm actually going to be tweaking a bunch of camera settings when I get my next camera set up, which I haven't had the chance to do yet. I really need to get my office tidied up, fix up a bunch of stuff, and rejig some configuration options. So, but that's coming. Right, let's get into it. So where we left off last time, we were just mucking around with session deserialization, config deserialization, and setting up sessions and transport configurations. And then we tried connecting our pseudo Meterpreter instance to a native Meterpreter listener, which didn't end up working as we wanted to, because we found out that the native Meterpreter listener serves up a native stage which doesn't actually reference how big the DLL, the MetServe DLL, happens to be. So we couldn't pretend to sort of skip it. So what we're going to need to do in our stager is, because we're generating this stuff obviously on the fly, we're going to have to come up with another way of staging this so that we can keep track of exactly where the configuration is. Which isn't that big a deal, really. It just means we need a new stager. But what I'm going to do at the moment, what I'm going to do in just a second, I should say, is I'm going to go back to Metasploit and we're going to set up a HTTP listener, and we'll just parse the configuration of a HTTP listener as well, just as part of our tests, and then we can sort of set up HTTPS based transports at the same time. So that will at least be the plan. So at least we can sort of instantiate / deserialize our HTTP based transports, and then from there, you know, hopefully make future web requests, which is something we need to discuss anyway. So, but as always, please fire off your questions as we go. If you have any concerns, things that don't make sense, etc., then feel free to reach out. Now, it is a Friday night, so I may end up only going for about an hour and a half tonight. It's been a big week for me too. So we'll see how we go. All right, so step one, we are going to need where are we? We're going to need to create a new Metasploit listener. I'm going to leave all this stuff the same and change this to, we're going to just leave it as HTTP. Later on, adding HTTPS is actually not that big a deal. So we'll worry about that down the track. It literally just takes a couple of settings to be tweaked and off we go. Okay, alright, so with that listener running, we should be able to curl HTTP localhost 4444 and see a configuration get spat out. I guess not. Is that the port I'm listening to? I'll have to specify the IP, won't I? 192.168.20.171. And yep, okay. Righto, so the reason why that doesn't actually give us any configuration is because we need to be able to what do we need? We need a proper UUID. We need a URL that we can throw at this thing that actually gets parsed by Metasploit and recognized as something that's attempting to connect, and hence requires a stage. So what we might do quickly is MSF Venom, Windows Meterpreter reverse HTTP, lhost equals 192.168, can't type again, .20.171, port equals 4444, format executable, output to scratch stream met.exe. Now while that's running, let's just quickly go to Windows Defender settings over here and make sure that the real-time virus protection is off. Ah, it's managed by my organization apparently. I didn't know I had one. Hopefully that means it's disabled. I'm pretty sure I've disabled it. Let's have a quick look. Yeah, Windows just turns its own shit back on again, doesn't it? I can't remember what it's called. It was MSPing or something. I don't think it's actually running. I think I went into group policy and turned it off because it kept turning itself back on. And for the purpose of this machine, I don't care if there's viruses and stuff on it, to be honest. OT Corp. No, it's just local domain. What an awesome name, hey? Apparently my extensions are managed by my org. Yeah, interesting. Alright, so with that generated, we should be able to go back to MSF console, let that spin up, go back over to our Windows 10 virtual machine, pull out met.exe, drop it on the desktop, and with that listening we should go and successfully connect. Alright, so I'm going to take this, do what we did before, and I've killed off all my Python code in here, which is dumb. Maybe I can see it in the backlog. Can. Only just though. Let me just grab my one-liners again. Hey Smash, thanks for coming in, buddy. Nice to have you up here. Alright, so let's just chuck this in because I'm going to need it. Now, what did I do here? I set this up, didn't I, to be this. Alright, so now if we take a copy of what we had here, copy x equals that, then we should be able to do what we did before, which is this print. What did I do? I gave it a, really? A equals lambda. I don't even remember what that is. The data is x 16. Oh, I've got to add the XOR capability, don't I? Fool. Chuck that in as well. What do you mean global name? Oh, okay, so now I have to give it all three. No, I don't. What have I done? Why is my copy and paste failing me? We have that. That should come out okay. We've got that. This is what happens when you try to get lazy. Now A, what is A? Lambda VS. Ah, okay, yeah, I see. That's my problem. K should be passed in to begin with. Yep, that's alright, we can fix that. So A needs to be redefined as that. So then if we do this, okay, there we go, we can see it now. So this is our HTTP transport configuration, among other things. Let's take a copy of that. And we will drop this in our little test program application. That's one. Actually, new list of byte array. We can do that, and then actually we'll do it prior to this one. So we'll go new byte array. Something in my ears that sounds like a really cool game. Come on, Viz Studio, do your thing. Okay, so that's the first one. That should be the second one. Okay, so now we've got both of the configs in here, we can just test them out. So for each var data d in, let's just map over those and call that B, which means the first one that we get should be a HTTP based transport, right? Let's see what this does. It's compiling. Always takes a little bit to spin up. What have I done? Come on. Talk to me, Viz Studio. Don't hang on me now. Something's not happy. It just died. Did you see that? Classy. Let's see if it dies again. Okay, where were we? Program. Data is new list. Oh, yep. I know what my problem is. We need to invoke it, which is config test. No B-side. That's right. Hey, null mode. Thanks for coming in, mate. Pleasure to see you as always. All right, so this should work this time. Let's go down to here. Build succeeded. Okay, I've got a breakpoint set this time at least, so that's good. Righto, so we now... Oh, I've got another follower. Slash subscribe. Oh, no. Subscriber. Hey, Atwolf. Thank you, sir. That's very kind of you for the tier 1 sub. You're a legend. Righto, so let's see if this actually behaves itself. So we skip the first 4 bytes. Actually, I should change this comment. It should be 8 bytes because that's what has the socket handle in it. Sick of the ads when I refresh the stream. It's good to know that that's the motivation. Ads actually work. Thanks though, mate. That's really kind of you. Alright, so let's have a look. Locals. This. So exit func. Let's view in hex again because I find that a little more helpful. Expiry 2019 17. So a week from now. That's looking good. Session UUID is stuff. And session GUID is other stuff. Okay, so that came out fine. Now we need to load the transport. So let's see what this says. So we're going to pull out the transport config, and the URL is HTTP followed by the big long URI, which is probably what we got passed in at some point. It's a shame you can't tie Twitch to Patreon subs together. That's a very good point. There must be, yeah, there's got to be somewhere where I can say, can you mark this person as someone who doesn't have to pay because they're already supporting in other ways. We should talk about that. Comms timeout, retry wait, etc. Comms timeout is typical retry. Actually, let's put these back to non-hexadecimal so that they actually make sense. 300, 3600, and 10. So that's exactly what we would expect to see. Alright, so now we've got to go and create a transport based on this. Now this is where we need to change the codes. Alright, so let's do that. Case HTTP, and we will probably add HTTPS to this particular case as well. HTTP transport this. So let's create a HTTP transport, which is an I transport. Okay, let's move that to its own file. Okay, HTTP transport, and we need to implement this interface, which isn't exactly handy. I'm going to get private set constructor, and we have a transport config which we will assign to the internal configuration, pretty much in exactly the same way that we've got it for TCP transports. Pretty much exactly the same sort of thing, right? And then at that point we obviously want to do some more deserialization. Because there's more to the HTTP configuration than there is other stuff. So once we've created this transport, we need to. What we probably should do is pass in the binary reader so the rest of the transport can actually be deserialized, right? Binary reader, and we'll bubble this down, I think. Now this may change. I'm not necessarily 100% sold on this idea for now, but let's see what happens. Binary reader. Now in the case of the TCP configuration, we don't need to do any more. Oh, actually, you know what? I don't think I will do that. So once we've created the transport, I'm going to go back out here for now. Transport equals create a transport based on that. And then what I want to be able to do is pass in the reader to sort of finish off. So let's go transport dot. We need to give it a function name. What are we going to call this? Maybe we should configure it. Let's do that. We can rename it later on. Oh, there's no get system bits thing. No, I'm working on my emoji foo or emote foo or whatever the hell it's supposed to be. The foo, all the foos. Now, we don't... So at this point here, we don't need to get any other configuration out in TCP transports. But we do in HTTP. Okay. So let's just wire that in. Now we need to... oh, by the way, Atwolf, there will be a get system thing, but in order to troll me with my own emotes that have get system in them, people are going to have to pay more. I might just give it to you specifically there. We'll see. Anyway, I hope everyone's got their tea. Tea is important. Alright, so when we're configuring the HTTP transport, we need... Let's see what else we've got in here. So that's the loader config. Here we go. So if it starts with HTTP, we may have proxy information. We've got user agent. We've got certificate hashes. So we need to have all of that sort of stuff checked in. So once we've, as you can see, once we've got this stuff in place, we add to the transport data proxy host, proxy user, proxy pass, user agent cert hash, and whatever custom headers there may actually be. Okay. So that means first thing we need to do is look at the proxy host. Now the proxy host has a size, so we're going to need to look at these sizes. Let's have a look. Let's take a copy of all these because I think we're going to end up needing them. Move from beer to a lovely gunpowder green tea. Fantastic. That's a very nice choice. What we like to hear. That's exactly what we like to hear. Alright, so I'm going to put some private constants in here. Hate that. Okay. Private const uint. Okay. So we have our sizes now. Oh, have I? Yeah, I thought for a second I'd done it in the TCP transport, which would have been stupid. Now we added an extension method to read strings of a fixed size, didn't we? So we want to go this dot. What's the first thing again? First thing was proxy host. Proxy host equals reader.read. Now, what did we call it? It was a wide string, wasn't it? Wide string? Yeah. Read wide string, and we got to give it a length, which is proxy host size. Did we do the ints? Yeah, we did, didn't we? Because length needs to be an integer. Yeah. Alright, fine. For the sake of this discussion, we'll just make them integers. Alright, so let's create a property. Get and private set. And we'll be doing the same with this dot proxy user equals reader.read. See? User. It's way easier doing it that way, isn't it? Pass. I'll call it pass because that's how it's referenced in the code. Proxy pass. Now they're the three that we pass in, right? Host, user, and pass. And the host should have like the full URL and whatnot in it. Next we have the user agent. I won't call it UA, I'll actually call it user agent. Yeah, C2F underscore UA size. I should have used T instead of F. Could have saved myself a character. And then this dot, what would this be? Cert hash equals reader.read bytes. So we know this is just going to be raw. Cert hash size. Alright. Hooray. Hopefully that will all make sense. Hello, who do we have here? BDCHT. I don't know how to pronounce that, but welcome to the stream. We're currently working on what is a new implementation of a rat slash agent called Meterpreter, and we're building it to run on the CLR. That's basically what we're doing. If you'd like to know what Meterpreter is, I'm sure a couple of people in the chat will explain it very briefly, or if you want all the details, you can have a look at the first episode in this whole development series that talks about what that is. But we're basically writing a bunch of .NET code to talk to Metasploit at the moment, and at the moment we're deserializing some configuration that comes across the wire as part of the staging process. So hopefully some of those words made sense. If not, feel free to drop more questions. There are lots of people who will be able to help answer as I'm bashing away at the code. Alright, so with those out of the way, we then have custom headers. Now custom headers, is that got a fixed size as well? I don't think it does. So custom headers looks like it is of a variable length. Interesting, hey? Hey Barney, you're here. Hey OJ from Will. Hey Will. How you going, buddy? I hope you're doing well, mate. I'm looking forward to coming down, catching up with you and going rock climbing. That's going to be awesome fun. Alright, so our custom headers look like they are going to be an arbitrary length wide string, which we don't currently have the ability to read, do we? We have the ability, I think, to read in our extensions. Binary reader. Do we have a... We can read wide strings, we can read standard strings. We didn't do anything with ASCII strings though, did we? Yeah, okay, so we can read wide based on a certain length. But we don't know that length up front, so we're going to have to do some smarts. I'm doing fantastic, thanks Will. So for those who don't know, Will is Barney's son. And he and I have never actually met, but we've had a lot of interaction behind the scenes. So I'm looking forward to meeting him face to face. We've got a budding rock climber in the room as well, which is awesome. So I'm very much looking forward to meeting Will next time I'm down in his neck of the woods and we're going to go rock climbing together. That's going to be great. So that's coming. That is coming. Looking forward to that very much. Okay, so let's think about what we're going to do. These custom headers, basically we need to read a series of bytes off the wire up until we get a null wide string byte, right? So in order to do that, public static string, we need to read let's go null terminated wide string. This binary reader int length. Does everyone know how extension methods actually work? Because if you're new to C# or you're not familiar with this syntax, it might actually be a little bit confusing as to why we have what we have going on here. Hands up if anyone wants me to briefly explain how extension methods work. Max are transferring the images will pack as soon as you're a legend, Barney. Thanks, bro. So yeah, anyway, extension methods, I can cover them briefly. Please do. Okay, nullcult, happy to do that. So here is the principle behind an extension method. Let's say there is a class out there as part of the .NET framework or part of a third-party library or something like that. And you're constantly interacting with this class in such a way that's a little bit abrasive. And you're like, you know what, I really wish this class just had this method. It would really be nice if I had this method. So, for example, the built-in binary reader, okay? So the reader doesn't have a read like wide string, it doesn't have a read null terminated string, it has a read string that expects it to be encoded in a B string style format where there's a length before the actual value of the string, but we don't have that. What we have here is a wide string that's null terminated. So what I want to be able to do, just like I would invoking read string on the reader object, I want to create a function that's kind of attached to that reader class that I can call anywhere in my code in a really nice and concise way, in a way that sort of looks like it's associated with a class that I don't actually have the source to. Okay, so Here you can see that we've created a class that's public static. Now the static class is important here. To make an extension to an existing class, you need to define a static method inside a static class. Now, I usually name the classes based on whatever it is that I'm extending, followed by extension. So here you'll see we're extending binary reader. So this is a class full of all the binary reader extensions. You'll notice that each one of these functions is public static bool, okay? So you give it the typical format, you give it how exposed it is, you have to specify static. This is really important, otherwise your extension method will not work. You give it a return type, and you give it a name. But the very first parameter, this is important, okay? The first parameter in this function, let's use this one here as an example. See how this first one here looks like a typical function, and it doesn't have the keyword this in front of it, okay? So this is a perfectly valid function and can be invoked. But as soon as you add the this keyword just here, the compiler goes, okay, so what I'm actually going to do is I'm going to treat this isFinished method as if it's attached to this binary reader, okay? So the code that you write inside operates exactly the same as any other function, but because of this static, and this keyword here, it makes it look like, for example, let's just do this. I'm just going to return null for a minute. It looks like it exists here. Now you'll notice in the IntelliSense, hopefully you can see that. So there's this read int64, which is part of the core type, and if you look at the little icon next to it, you'll see it's like a little cube. But this read null terminated wide string is an extension method, so you can see there's like a little downwards pointing arrow on the icon, which indicates that this is an extension method. How the hell did you just do that? Visual select and delete. Yes. No. Control V J. Yeah, I think actually I did. Sorry. Yeah, so I just went like this. Selected and pressed X. Yeah, that's exactly what I did. You could get fancy with regex and all that sort of stuff, but I've just felt like that was the... You could have done it slightly faster. Maybe like... Oh no, that wouldn't have been faster. Yeah, maybe my selection mode really isn't that good. Whoops, what am I doing? Oh yeah, I've done stuff since then. So yeah, that's all I did. I just quickly visual selected it. That was totally the way to do it. Cool. Okay, so we need to be able to iterate over the array as we see it. So what we need to be able to do, would it be fantastic if we could convert this set of bytes into an I enumerable? How cool would that be? We could do some really cool stuff then. I wonder if we could do that. Oh, we absolutely could. Oh, this is kind of exciting. Should we add this? So if we went public static I enumerable of byte. I enumerable of byte. Okay, I'll probably need to add a generic collection so that we know what an I enumerable is. Let's go as enumerable to keep it consistent. This binary reader. Okay. Now how cool is this? If we go like this, while reader dot is finished. Now we actually don't. We can go not finished. I wonder if this is gonna muck with anything. We could probably bail out early. How about we go like this? While it's not finished, yield return reader dot read byte. That's cool, hey? Can you please send me a video of your rock climb? Yes, I can do that, Will. Absolutely can do that for you. Who has just followed? Cairo. Thank you, Cairo, for the follow. Very kind of you. All right, so this, what have I done? I need to collections.generic. That's my problem, so we can get rid of collections. All right, so see what I've done here now. There's a little bit of assumed knowledge in there. If what I've just written here doesn't make sense, speak now because I'm happy to explain this. And now I'm going to do something horrible, but fabulous at the same time. Okay? I love doing stuff like this. And I know it's really awful, but anyway. So, What we need to be able to do is probably, instead of read byte, yeah. Let me have a quick think about what I'm doing. I'm getting all excited and probably partly ahead of myself. You see, wide strings come in 2-byte chunks, right? So we basically need to iterate over until we get like in blocks of 2. If that makes sense. Nullcal, do you know Cairo? I seem to recognize the name myself, to be honest. So what I wanted to be able to do is maybe instead of as, let's go as byte stream. Okay. Now we want to kind of do the same thing here, but instead we want U short. So I'm going to go as a U short stream, and instead of read byte, we need to go read. What would it be? uint 16. Now that's another extension. Is it an extension, isn't it? No, it's not. See, it reads a 2-byte unsigned integer from the current stream using little endian encoding and advances the position of the stream by 2 bytes. Now let's have a look at what this actually looks like. Okay. Now, wide string is 2 bytes, so it is 16. So what we need to be able to, this is where linkiness comes in. We can go this dot, no, we want to go reader dot as U short string dot take, is it take? We need to add link. Okay, as U short string. So now we have an I enumerable. We should be able to get some take while. Here we go. So the value that we receive, so the character does not equal 0. Okay, so that will give us the wide chars as an array. Okay, now what we need to be able to do is take those wide characters and basically munge them into a byte stream. So, are we over engineering this? I kind of feel like we are, but those extension methods are cool. What I might quickly do, we've got a read packet U short read string keyword D word. I'm going to do the same thing here with uint 16 and read word. Okay. So this would be short and cast that back to a uint 16. There we go. So we can actually read words, and that's effectively what this should be doing, right? So this would be read word. Yeah, I think it'd be useful. So now we have a bunch of basically 2-byte blocks. Let's have a look at what this would look like. And to do that, all I'm going to do is go return null and set a breakpoint on it. And we're going to read a null terminated wide string from here. Why is that complaining? Read null oh, I've got to go, and we don't want a length. That's the whole point of having this, right? Did I do something silly? No, I didn't. Okay. Alright, so we don't need the length, we just want to say read the null terminated byte stream. So let's just see what this looks like. If you guys want good investment in your learning, check this site out. Thanks, Barney. Oh, now isn't this interesting? See how that came back with an array that didn't have anything in it. Okay, so let's go here. And we'll run it again. Ooh. Swearing. I can hear swearing, can you? Sorry about that. So it shouldn't be finished here. And if we call read does C equal 0? It does, and that's why. Okay, that's pretty interesting. So does that mean... Oh, that's... You know what that means? I know exactly what that means. So here's what we're going to do. The reason why is because we haven't specified a user agent. Right, so we can see in this block of crap. Can you see a user agent string? I can't. And there should be one, really. Alright, so if we do this... Excuse me. Let's go set HTTP user agent. I think that's what it should be. Let's go twitch.tv 1.0 custom user agent. Seems legit, right? So that should actually be passed in as part of the configuration, assuming that I have that correct. Oh, I'm stupid. I need to put a little semicolon in here. Add it to all the detections. All right, that's a bit better. Oh, what happened there? Is my okay. That's because we still have Meterpreter running in here. So let's kill it off because it's just going to interfere with us. There it is. Resilient shells for the win, hey? Okay, here we go. Let's spit out another config and see what it looks like. Hopefully we'll see something that should resemble. Let's have a look. Oh, hang on. Why is it that I specified a custom user agent? I don't want a user agent. I want a custom header. That's what we're parsing. Dumb. I am dumb. Let's kill that off again. It's not that we want to specify a custom header. The question is, how do I specify a custom header again? Let's just fire this up and look at the advanced properties. I think it might just be HTTP header or HTTP headers. If anyone else knows, then please let me know. Let's have a look. HTTP host header. An optional value to use for the referrer. Here we go. So that's right. We actually take things like HTTP cookie, HTTP referrer, and HTTP host, HTTP host header, for example, and they get baked into the custom headers. So let's add a cookie. Let's add a cookie. We don't need to worry about the user agent. Let's set HTTP cookie to doesn't really matter what it is, does it? Let's just go foo equals bar. Does anyone know the origins of foo and bar? Alright, let's see if we can see it now. Let's have a look. Can you see it? It's a wide string encoded thing, so... Oh, here we go. Foo and bar are down the bottom there. Excellent. So, let's take that out. Ugh. It's frustrating. Copy. Stick that in our Python. print it out as a byte array, and we'll probably just replace this with, replace the previous one with this. Okay, inside our code base. KNRC. I think it comes from earlier than that. I believe, Gombos. Now, I've just messed that up because I should have copied and pasted that after the fact. Copy, paste. Come on, over you go. We want some formatting at least. Okay, let's try that again. Pardon me. Alright, yield HR. Oh, and there's another one. And, oh, that's exciting. That's a bit better. We actually have some wide characters coming out. What do they look like? View as hex. Okay, 4300. Now we actually don't want it that way around, do we? Pretty sure we don't. So here's the problem that we've currently got, right? I want to be able to read in chunks of 2 bytes, and in order to do that, I've got to read in this manner. That's a good question. I have a vague idea of where the history may begin, Gombos, but I'm not exactly sure, and it's not in line with that. So maybe we should do a brief history lesson once we've got this little piece done over. But anyway, I need to be able to read in 2 byte chunks because for a null byte to come out, I need 2 consecutive null bytes, but I don't want to include the null byte that was maybe part of the previous character. So it has to be in 2 byte chunks, okay? And so what I want to do is once I've got all of these wide characters, I want to convert that basically back to a byte array so that we can basically deserialize it as Unicode, if that makes sense. So what we can do, I mean, this allows us to iterate over the byte stream, but what we probably should do is map over those bytes. This actually shouldn't be word, it should be uint 16 because it's byte swapping when we don't want it to. At this point, we don't want it to byte swap. So what I've done here, and the reason why I've done it this way is because I'm trying to lazily evaluate where possible. So what I'm doing is I create this IEnumerable extension which returns, this yield return basically says I'm going to return a value, but I'm going to leave my iterator sitting here so that next time they iterate over the next value in this enumerable list, this function gets called again, right? And you'll pull the next one out. It's quite clever. So what I'm doing here is I'm saying take from this IEnumerable, which is this thing here, all while we don't get a null value, right? So we're basically iterating until we get a null U short. Okay, now once we've got those, what I probably want to do is split them into bytes. So we want to go select, and here's what I tend to do when it gets a bit long, is I put it on separate lines so it becomes a little bit easier to read. So what we want to do is we want to select the character, and we basically want to convert that into a very small byte array. But this is the thing I kind of don't like. We could convert it directly to a string or 2 bytes. It's kind of messy, but you know, at the end of the day, we're not that fussed. We can come back to that. So let's just create a new byte array. And the 2 bytes that are in it are the character and OXFF. Now that's going to complain about the type, right? So it can't implicitly convert int to a byte, which is interesting because it should be a short, not an int. But so what we're going to do is we're just going to, in fact, we don't even need to truncate it that way, because if we just byte, if we go byte C, then that'll truncate it. But we also need, we do actually need to truncate this bit. So we're going to have to shift that down, or what is it, 8 bits down, and convert that to a byte. If that makes sense. So we're just kind of shifting. It's important to know expected length of wide characters. In our current context, wide characters are definitely coming down. They are definitely 2 bytes. That's how they're encoded on the MSF side. All right. Now, that gives us effectively an array of arrays. Have we got a flatten function in here? We already done flatten. Yes, but it's got to be an IEnumerable, which it is technically, because an array is an IEnumerable. I wonder if we went list of byte, whether that would be. There you go. We can flatten that. Right. So let's just see what this looks like. So our wide characters. Yeah. This is important. So all of basically everything that we had done there defines the operations that we want to do, but we haven't actually done it yet. So we need to convert it to a type. What's going on here? I think my cable connection is screwing up again. Probably full of water. Buffering. Is anyone else getting buffering? Little blurry for you. Full screen? Okay, so let's have a look at what we've got here. So wide characters, 43006F00. Okay, so that's looking better. Once we've got those wide characters, what we actually want to do is convert that to what we're doing here. Okay. So var s, what? That's bloody irritating. Hooray Visual Studio for being silly. Wide charts. Let's just have a look at what this does. It may buff, but it may be exactly what we want. Oh, look at that. Cookie equals foobar carriage return new line. So that's done exactly what we wanted it to do. Does that make sense? So here what we're doing is we're cheating. We're iterating over wide character stream, converting mini lists, flattening them. Basically we're breaking it up into 2 byte chunks and making sure that we get a valid null character in wide character format. Then we're splitting them back up into different lists, flatten them into a single string, and then reverting, which is messy as, right? Is that a list comprehension in C#? Not really. It's more of a functional style. Like, you should be able to read it. So we've got this reader, and we say, right, I want to just pretend that that is a stream of unsigned shorts, which is what this does. And it's lazy because of this yield, right? So as a result, we convert that to a stream, and then we can say, right, iterate over this stream and keep taking values out of the stream while the value that we get out is not null. Okay? And then it'll stop. At which point we can say, right, of the values that we've taken, we want to map, which is the same as select. We want to take that character and split it into its byte components. Then, because we end up with basically an enumerable of lists, we want to take those sublists and flatten them into one big one, which gives us a list of bytes, right? So then when we go .toArray, we will end up converting our IEnumerable of byte to a byte array. Does that make sense? So the dot select it's still not like a list comprehension. It's still more like map in Python. So for some reason in .NET they chose the word select, and I think it could be because the word map sort of has other connotations. Like a map can be like a hash map or a dictionary, but the map function, where you are applying a function to every element in a list and getting a new list with the results of all of those function applications, that's exactly what select is. And then we flatten it so that we go from a list of lists just to a list, and then we to array. Does that make sense? Hopefully that was a better explanation. Apologies if I did a poor job. Recently joined, and it may be unnecessary, but what about in an underlying stream? So we have to assume that in this scenario, so in your case, what you've highlighted there, so there's AA followed by a null B, followed by BB, followed by a null. So that's an odd number of characters to begin with, which technically isn't a wide string. Now, what we have in this case is, oh, we've got 100 bits. Thank you, Wolf. What we have in this case is we know we're getting a proper wide string. So we're definitely getting an even number of bytes at this point. Now we're taking 2 byte chunks because we're iterating over this stream as if it was U short. So we know we're getting 16 bits or 2 bytes for every character. So the null byte, the first null that you've got there in front of the B, the null and the B will be joined together, and then you'll get 2 more Bs followed by a null. So you would either need another character after that null or another null. I mean, every my character is wide. Okay, so if every single one of those characters in your example there is wide, then it would stop at the first null terminated entry. And that's fine, because in this context, we know that the configuration that we are being given is set up so that we just need to iterate until we hit the first null byte. Okay, so if there's anything after that, it's actually not part of this part of the configuration. It may be part of something else. Reader position is lost. Well, it's not, because we don't continue iterating beyond the first null. Does that make sense? We can test that too. So let's dive into that a little bit, because that's certainly worth talking about. Now, where are we? So here you can see there's still more at the end, okay? So we're going to have to continue parsing the configuration at this point. Yes, and this is really important, Yuko, because this will only, the code that we were looking at just then, where is it in the extensions? Binary reader extensions. So yes, while it's not finished, what you got to remember is that this will get called for every value that is requested. Okay? So when we take while, we actually stop requesting characters once we hit the null. So this does not get called again. And then as soon as we leave the scope of this function, then the closure that wraps over this is no longer required. Okay, so there are still bytes left in the stream. It doesn't continue reading them behind the scenes. It stops. So we're gonna look at that right now. This is a really good point. So thank you for asking this question. Okay, so once we need a separate function reader is not finished, so you don't need. No. All right, so here we got the null terminated Y string. This dot custom headers. That's what this is. Equals. You can tell that this was added on and is very different to the fixed length string. So what we'll probably end up doing is changing this down the track. So rather than having a fixed size for all of these things, they all take arbitrary sizes. It does make it easier to parse when it's not arbitrary sizes. So that's what the custom headers parsing looks like. We'll come back to in a minute to get Yuko's question. So the custom headers comes out, and then immediately after this, we get to the end of our transport configuration. You can see it's terminated with a null character. Okay. So that is then consumed by the caller of this function, this configure function, which is inside the it's inside server configure, and then we loop, and then eventually we skip the underlying terminator at the end. And then when that's done, we go to load extensions. Okay, so by your reasoning, GetUko, if we have finished going through the entire stream, this call to read uint32, which, let's remember, should stop as soon as it gets to, hang on, where are we? So that's A00. There's our null terminator, and then there's 1, 2, 3, 4, 5, 6, 7. Sorry, that might be all of those. All of these bytes are null, so we skip the null terminator, and then there's 1, 2, 3, 4, 5, 6, 7. There's still 8 bytes. And so that would be, first of all, the terminator for the extension size. So that's 4 bytes, and then what do we got here? Terminate the last part of the init config with a null byte. Okay? So we'll try and understand exactly what's going on. Alright, so I'm just going to run this. And so when we get here, the theory is that now that we've got our transport configuration, so this transports, we have one HTTP transport with a config, and we can see that custom headers contains cookie foo equals bar. We have our custom user, our standard user agent string. We have no proxy host, proxy user, or proxy password. So we can see that we've deserialized this in the way that we were expecting. There should still be bytes in the stream, right? So if the loop had continued beyond the string that we were reading, this would not work, right? But as you can see, it has. So the size is null because we haven't actually given it an extension to load, and so it will skip over this. And then there's this load extension, init extensions, which we already have. Oh, check this out. Load extension initializations. So this, for example, this is what we were doing the other day, remember? We were pulling out the extension name. So we should be doing something similar to pick out arbitrary length standard strings. Let's do that. And then we can sort of really tidy this little piece of code up, which is quite nice. Okay. Yeah, let's do that. Okay, so from here, like we should be able to just go through and finish up, and we've basically read everything off the wire that we were hoping to read. So going back to our, does that answer your question there, GetUko? So just to be 100% clear, when we stop iterating over the stream, then the closure that's doing the loop and the yielding that we have in our extension here, this yield, this whole function doesn't get called again. We effectively stop once we terminate with this condition. I hope that explains it well enough. So do we know that this is ASCII? Is that what we're doing? Yeah, it is. I might even just use that as UTF-8. And instead of wide chars, we're just going to go chars. Chars reader dot as, what do we call this again? Binary reader extensions as byte stream. Yeah. So null terminated. We'll just call it null terminated string. So this will be as byte. Have we lost GetUko, by the way? I'm hoping that that's going to at least explain where I'm coming from, mate. Now we don't need to map this because we know they're standard bytes, and we don't need to flatten it. Depending on context, we have side effect on reader. Yeah, we do. That's exactly right. So if you iterate over it as a stream in the way that we have here, it will only, like, you can keep reading bytes until you get to the end and it will stop. But you can also keep reading bytes and you can terminate it early, which is exactly what we're doing here. We're just going to take a while. So this should mean that we should instead be able to go, what are we trying to do here? Check to see if we've reached the end. Get a reference to the extension and pass the init source on. Now it's going to be hard to test this because we don't actually have extension bytes in. So maybe what we should do is actually simulate that as well. Okay, so we can't do that unless it's stageless. We can't actually pass this information down in the configuration at this point, which is a little bit shit. Yeah, we can't, that's a little bit frustrating. Because I really would like to test that. But effectively what we want to be able to do is do this. var ext name equals reader.read null terminated. Come on. Is that what we called it? Null terminated string. Oh, we've not got the extensions here. There you go, that'd be why. So we read a null terminated string and we would go while extname.length is greater than 0. We then need to do basically what we were doing here, right? Okay, do what we were doing and then go ext. Going on, what have I done? Yeah, no, that's fine. ext name equals reader.read null terminated string again. Hopefully that makes a bit of sense. So that's the kind of thing. Now what I'm going to do is I'm just going to comment this out in a dirty way. If def this isn't a thing, and we can comment out all of the other stuff. So that basically will get compiled out. Sorry, not if def, just if. Yes, that's true. Yep, that's true. I was thinking exactly the same because we don't include it. Thanks, Smash. Okay, so that's basically what we're looking to do from this point on, which tidies this piece of code up a little better, hey? Assuming that it works. And when we get to the point where we can actually load extensions in this way, such as through a stageless configuration, then, you know, that would be good. Pardon me. To be honest, I think it would be cool to be able to specify the extensions and the XT-init stuff in exactly the same way on a staged connection as stageless. But, you know, when you're in that context, it makes a lot more sense to only send across the wire what is absolutely necessary. So that would just be just metserve, just so that it can bootstrap and turn communications into something that's encrypted before it pulls in more information. Then it's less plain text stuff on the wire. Okay. Is everyone cool with what we've done so far, at least? So we should, we now have the ability to deserialize HTTP and HTTPS. Now I'm not going to create a separate transport for HTTPS. So HTTP and HTTPS is basically exactly the same, particularly in a .NET context. It's just that when you make web requests with HTTPS, you may need to turn off the cert validation, and pretty much everything else should remain transparent. That's effectively my thought as well. And so once we've configured stuff, we've finished reading our configuration, whatever the current transport is what we should start dispatching. So once we've created the server, at this point, this is where we effectively want the server to kick in. Okay? So we would look to do something along the lines of server.start. Okay. Public void start. Okay, so this is us saying I want you to start your dispatch loop and all that sort of stuff. We will probably do more initialization here, like we will most likely set up some kind of scheduling and a lot more accounting around channel management and various other things. So what we want to be able to do is we need to maintain a reference to whatever the current transport is. And the current transport will be the first one that we've serialized, right? So let's go with this dot current transport equals whatever the first transport is. Okay. Generate field. Hopefully it's not read only. There we go. Current transport. Okay. Now here's where we're going to have to start thinking about our dispatch loops. Now in other Meterpreters, the implementations are all very different for a number of different reasons. But what we need to think about is we need to start keeping track of when we read our packets last, whether or not the current transport is actually connected or not. Now, which that actually doesn't make a lot of sense in the sense of HTTP, but it does in TCP. But we need to sort of abstract that and go, okay, well, for the current transport, we want to actually connect, okay? Because in TCP land, that's what we will need to do. In HTTP land, we don't, but we can simply not connect in HTTP land. We can easily handle that in other ways, okay? So, basically what we need to do, now we've got a reference to what the current transport is. We may find that it actually makes a lot more sense to maintain an index into the list of transports, because as we roll over the transports, we will find, for failovers and things like that, we will probably find that we want to loop through the transports, and if they fail to connect or they somehow disconnect or packet dispatching fails, we want to roll over to the next one. So, you know what I should do? Instead of doing this, let's go back to our IEnumerable extensions. Here's an extension that I really like, right? Public static IEnumerable of whatever it happens to be. Cycle. Who knows what I'm about to do here? Does anyone know? If any functional programmers out there? We've lost Jono abroad recently. It's a shame he's not here. Take a bike ride. That's right. We're going to play some Queen and we're going to ride our bikes. This is what we're going to do. While true. Yes, we are doing an infinite loop. For each var e in elements, yield return e. Yeah, you can see where I'm going with this, right, Smash? Because then what we can do is go like this. So we can basically go like this. For each var transport in this dot transports dot cycle, and this will basically continually iterate over our transports. Why is this a bad idea? I love this idea, by the way, but it comes with one assumption which we can't actually make. So what is it? Can anyone tell me? Nobody? What happens when we need to never finish and block the main thread? Well, that's fine, because what we'll end up doing is, while we're going over our transports, we're going to be keeping track of a counting that's specific to the transport to make sure that we can try and connect on that transport enough times based on the configuration. And if it fails, we need to roll over to the next one. But we also need to keep track of how long the session goes for. Okay? Bingo! Thank you, Smash. Exactly that. Does it handle transport size changing? No. That is a problem with this. So if you add a new transport on the fly, which you can with Meterp, or if you remove one on the fly, that's going to fail. In the case of transport length of 0, that is technically not a possibility. Okay, because there is code in all of the other Meterpreters, and there will be code in this Meterpreter that says, if you're trying to delete the current transport, I'm not going to let you do that. You need to have an active transport, and you can delete other inactive transports, but you can't delete the current one. Okay, so that's basically why. Now I'm going to leave the cycle function in there because we will find uses for that, but we can't actually use it in this context, right? Bad transport, no deleting yourself. Exactly. So I'm going to ditch this, and what we are going to do is we're probably going to need to get a little dirty, I think, because we need a list that we can iterate over, and then we need to have the actual list of transports. So it's probably fair to say that we need to kind of take a copy of the list to iterate over it. Or do we? Let's leave our current transport in, because that's definitely where we're going to start, right? And what I might do is start off like this. So we have a reference to our current transport, and we have a reference to whatever the current transport index happens to be, okay? Because what we want to be able to do is this. We want to loop, and we want to continue to try and connect based on the parameters of the transport, okay? So here's where we're going to have to start maintaining reference to time, okay? So for every single transport, we have a retry wait, a retry total, a communications timeout, and we have the overall session timeout, okay? So remember that in our session configuration, our session config, we have an expiry, which we have figured out on the fly. So what we need to do while we're starting is we need to constantly check to make sure that we haven't expired our current session. And if we have, let's just do this for a minute. While true, we know we're going to be looping at this point because this is our main dispatch loop. If datetime.utcnow is greater than this.session.expiry. Have we expired? Yes. So that's basically us saying, as part of this, as this in the start of every single loop that we do, regardless of what happens, if the session has expired, we've reached our timeout, we need to exit our main loop. Okay? And we will have some shutdown code and whatnot once we exit this loop. But it's really important that that we manage this in this way. Okay? So what we need to do is, for the current transport that we're using, we need to try and connect to it over a period of time, okay? So we need to keep track for the current transport when we started, right? So we've got our current transport. So this is the basic accounting. This is like, we'll go initial setup, okay? In fact, that's a useless comment. Let's get rid of that, and we'll do this. So while true, we're just going to keep an infinite loop here, which will actually drastically simplify things. So what we want to do here for the current transport is we want to try and connect every however many seconds until we're told not to. Okay? So that means that for the current transport, which has a configuration, inside that configuration we have a retry total. Okay? So for this, we need to have transport expiry equals this.current transport or config.retry total. We need to add that to datetime.utcnow.add seconds. So we know that that's the seconds, right? So that's basically how long we are allowed to continue trying the current transport, okay? So, while not, we're going to go not this.currentTransport.connect. So while we're unable to connect on the current transport, we need to wait. Milliseconds timeout, time span. So we can go this.currentTransport.config. We just had another sub. Follow. Thank you, TG4L Aaron, for the follow. Very kind of you. So here's the question, right? When we call connect, do we delegate the responsibility of the transport trying to connect itself and managing the time by itself? Or do we handle it a level above? In my opinion, we handle it a level above, because then we have the connection code, sorry, the timeout code in the one place. And more importantly, that it's very clear on a per transport level exactly how this stuff is functioning. We remove the duplication in code being the big one. It does mean that, you know, we're kind of making nested calls. What we could do is just go, you know, this.currentTransport.wait or .config.wait or something along those lines. But I don't think that's particularly intuitive. It actually pushes logic down into the configuration that isn't really configuration specific. Connector just connecting, right? Not managing stuff. Correct, yes. We're going to implement that in just a minute. Is that another follow? Ged Yuko, thanks for the follow, mate. I really enjoyed your question earlier today. And that implementation we've got there is not necessarily the most ideal, but it's a creative way of solving the problem. We may come back to go, you know what, that is not the way that we want to solve it. But I really dig that question, so thank you. Retry wait, which as we know is in seconds, so we'll have to times that by 1,000 because this function is expecting milliseconds. And it's expecting an int. Why is everything expecting an int? Just don't get it. Okay, so while we're unable to connect, okay, we need to sleep. And we need to make sure, and start method should be do work. And the start method should not be do work. Is the implication there that it needs to be on a background thread or something along those lines? I mean, at the end of the day, this is going to be in its own thread at the top level. So I'm not quite sure I understand your question that time, Ged Yuko. If you could explain that a little bit more, that'd be really good, please. So remember, for each one of these, we need to wait, and then we're going to try again. Now, between each one of those waits, we need to check not only if this... Yeah, so we need to check not only that the session has ended, we also need to make sure that we haven't reached the end of the transport expiry for this particular transport. Okay? So after we sleep, we come back in here and we go... Let's check it in here. If... sorry. So the transport expiry... Okay? The transport expiry... Where are we? Is less than... No. Is greater than datetime.utc now. And we're unable to connect. Now what I think I'm going to do as well is I'm going to probably remove... Oh no, I'm going to leave it the same. I'm going to leave it the same. Ignore my rambling. So here I've got to check, make sure that this transport retry timeout has not expired. Sleep for the requisite requisite timeout between reconnect attempts. Okay, so that's basically what that means. Okay, so here we're clearly not checking the session expiry, and that's something that we absolutely need to do. But what I'm going to do, rather than handle the session expiry in that way, I'm actually going to put this in a try catch. Okay. Some people might not like what I'm about to do. So, if we catch an exception at the top level, we're going to actually layer our exceptions a little bit. But effectively, what I'm going to do is if we end up with our current session expiring, then we want to be able to bail out pretty much at any level. Okay, so what I'm going to do is I'm going to do this. I'm going to go private void check session expiry, and this is going to make it really easy to check, right? And we're going to do this. I'm going to take this out, put it in here. Oops. And then if it has expired, I'm going to go throw new timeout exception. Message, session has expired. Okay, so this means if we can catch a timeout exception, then we know the session has timed out, clean up and shut down. Okay. Aha, okay, so start will actually mean start the server. As part of starting the server, what we're actually doing is not doing work per se. We're going to set up some, we're going to set up schedulers. We're just currently working on a dispatch loop, which is tied to the transports. So what we may find is we'll take this piece of code out and moving into a separate function and invoke that in a different way. But right now I know that transport management is something that has to kick off. Maybe what we should instead of calling it start, maybe call it run. That's probably a little more intuitive. Start and run are kind of the same thing, but run implies like it's going to be going away and doing its thing. Start maybe implies that there's some kind of asynchronicity or something going on, which there isn't. Pardon me. So this basically means that I can go check session expiry here, and we can quite easily call this at any point. Okay. So what we can do here is we can do, we need to basically have a flag to determine whether or not the current transport is connected, because if the current transport failed to connect for each one of those we then we're going to get to the end of our transport expiration and we need to go, oh, okay, well, we failed to connect on that transport. Let's roll over to the next transport. Okay. So what we'll want to be able to do is go, right, if not this current transport dot is connected, we'll have a little flag that says whether the current transport is connected or not. Because this, you know, the connect versus is connected will effectively refer to the same thing. We kind of want to continue to connect each time, but we want to bail out when things fail to connect. So if it's not connected, we basically want to go this.transport index equals this.transport transport index +1 mod this.transports dot length. Is it length or count? Count. Okay, so that's just us iterating over the list. And so this dot current transport equals this dot transports this dot transport index. So that's basically us going, right, we'll use our index to move to the next element in the list, and then point to the current transport at that list. And then here we're just going to go continue. Okay, So that means we will bail out of this and come back to here, and whatever's in place over here immediately after this condition will continue to function. We'll go, okay, well, we know that we're actually connected, so we actually want to start dispatching packets off that transport. Okay. So if it fails, we will go over here, and then we'll set up, based on the current transport, what the retry total is, and we'll come up with a new expiry. And then from there, we will basically loop again. Okay. Now let's quickly implement these. Let's go to our transport interface. So we have a bool connect and a bool that is connected. I'm going to make this it's not going to be a setter at the top level. We are just going to have a getter. All right, let's implement these extra doohickeys. So we are always going to return true in the case of the HTTP-based transports, because the concept of being connected doesn't make a lot of sense. I pondered that, Mongo. Also, welcome. I didn't know you were on stream. Yeah, to be safe, we probably should do this, hey? I think I can hear the rain absolutely pounding down outside through my speakers, so it must be pretty heavy. Okay. So that just makes sure that that's all good. So for HTTP transports, we are always going to look like we successfully connected, and from there we're just going to try and dispatch packets, which is a little bit frustrating, but because of the connectionless nature of this, it's kind of hard to do anymore. Okay, so we're just going to hard code each one of these. Let's just do it this way so that we don't even duplicate this dot is connected, which we know is always true. Whereas TCP is a different kettle of fish. Is connected. This will be a get and a private set. Man, it is bucketing down outside. That's pretty savage. Okay, so based on our current connectivity, we need to, basically what we need to do is this. If this dot connected, is connected, return true. Now tell me why I'm doing this. Oh, you reckon? Nah, it's definitely bucketing it down. Trust me, it is hammering down outside. Can anyone tell me why we're doing this? Picture a scenario where we call the connect method on the current transport and it's already connected. Anyone? Don't want to kill a connected session. Right, okay, so to extrapolate that a little bit further, Gomboss, what that means is, let's pretend that is it a relay? No. So the story here is that for a TCP-based transport, okay, once we've staged, the implication is that we've already got a socket talking to Metasploit. And so what we will have is a mechanism to say, okay, we want to wrap this we want to configure a transport, but we also want to pass in the current transport sort of implementation. Or I should probably more accurately say, we want to pass in the TCP socket that we're currently using. Okay? So that would mean, in the case of this, so when we create this TCP transport and we get a transport config and then we configure it, we're probably also going to pass in some other metadata that references how we were connecting here in the first place. So in the case of a TCP connection, see you in null mode, no worries, mate. In the case of a TCP connection, we have an active socket. We want to give that to the transport config so that it can continue to use it. If that's the case, then it is already connected and we don't need to reconnect. Hopefully that makes sense. So if it's not connected, then we want to go through the pain of doing whatever it is that we're going to do. Now, at this point, we can probably start doing some kind of smarts with async comms and whatnot, but we won't worry about that just for now. In the case of a TCP stager, like what we've got, where is it? Where did we do it? That's just config checking testing, isn't it? Oh, we had it near the top, didn't we? Here we go. TCP connect. So for example, we want to create a new server and give it basically all of the things that we've got. And what we want to be able to do once we've deserialized all of our stuff is we need to be able to pass a reference to the active transport so that we know we can hand off whatever connectivity we currently have. So what I'm actually going to do before we run is I'm going to put this current transport related bits and pieces here. Okay. And then what we can do is at this point, so hang on, we've got metserve, new server, we can go metserve.run. Okay, so what we also want to be able to do is pass the current socket down to, what's it called? Pass the current socket down to the transport somehow in a fairly sort of generic sort of way. Now the problem with doing things like this is that we end up getting a kind of, we're polluting. We've got this leaky abstraction. We're abstracting transports inside metserve, but something at the top level needs to go. I know you're currently talking on this TCP connection, so I want to give it to you. Okay. So what we may need to do is have an overload of this run function. Okay. So we could have a function like this, and that takes, for example, the TCP client. Okay. Now this is where that leaky abstraction thing comes in, and I'd love to hear people's views on this because it's pretty horrible. If we pass in the TCP client, then the expectation here is if, hang on, let's go transport equals this dot current transport as a TCP transport. Okay, so if the transport was successfully cast to a TCP transport, so it's not null, we know that the current transport is a TCP client, and we can say, you're a TCP client, sorry, a TCP transport, let's give you the TCP client. Okay, so we can go transport dot, we'll say wrap, because we effectively want to wrap around the current TCP client. Does that make sense? Can't you just put if transport? No, I don't think you can. But let's try it. I'm pretty sure you can't, because it's a reference type, see? And you can't implicitly convert a reference type to null, and you have to check for not equals null. Okay, so for now we're just going to assume that where are we? TCP client equals TCP client. Now, this is connected. We're probably not even going to have a private set at this point. We may actually change this so that we actually have a getter. And the getter says, return this.tcp client is not null, and this.tcp client dot, is there a connected? There you go. So that'll tell us whether it's connected. So here, we can basically do some accounting again. So you'll notice that we've got, where was it? This. Right? We can basically do the same thing here. Now it's okay to copy and paste at this point because remember, this is going to be part of a stager, which is like completely different code base. Okay? We basically need to do the same thing here. So if it's not connected, the assumption is that we don't have a TCP client, right? What I do need to do is make sure that these transports are disposable so we can force the cleaning up of our resources. And we'll do that in a minute. Actually, we might not get to that tonight. So we're going to have a TCP client, and we're also going to have a binary. I think we're going to have a binary reader. Okay, so when we have that, we're going to have this dot TCP reader equals new binary reader, and we're going to wrap this dot TCP client. Doesn't matter that another one further up has actually been, has been created. Let's just make that public for now. All right, so then what we need to do is TCP client is new TCP client, and we're going to try and connect. Now, what we need to do is we need to be able to parse our internal configuration in such a way that hang on a second. Oh, that's right. We need a network stream as well. Private network stream TCP stream. So this TCP stream equals new network stream this dot TCP client, and then here we have TCP stream. Now I know it's messy because of what I've got written here because of these using statements, right? Network stream TCP client dot get stream. Is everyone au fait with what we're doing here? Now, why can't we do that? Ah, that's why. Okay, so what's missing? We need to do this, don't we? Okay, that's a bit tidier. So we have the TCP client and we attempt to connect. Okay, and if it's connected, actually what I'm going to do is I'm going to create a local variable here, TCP client, and in fact I'm just going to call it client to make it very clear we're not talking about our local method, our local member. Okay, and if it's connected, if we successfully connected, we want to go this dot wrap client and basically invoke this. Okay, and at this point, this is connected function will determine whether or not we actually have connected. Okay. So one more thing that I'm going to quickly bash out is make this disposable. Pardon me. Did I type that wrong? Dispose bull. There we go. All right. So that basically forces each one of the transports to implement the dispose function. Okay, so we can go if this dot TCP reader doesn't equal null, then this dot TCP reader dot dispose. Does it not have a dispose method? I guess it's not disposable. It is disposable. Dispose. due to its protection level. Is it? Why would that be the case? Public. No. Yeah, it's public. Why are you whinging at me? Someone tell me what it is that I'm doing wrong. Binary reader dispose bool is I'm not calling that method though. Protected virtual bool dispose. Yeah, that's the thing. I'm not calling that. But it's iDisposable, which is public. Dispose method of the interface is implemented explicitly. Ah, thank you. That's a good point. Thank you, GetUK. You're dead right. So if it's explicit, then we actually have to cast this to an iDisposable. Subbool. Interesting. So I wonder why that's the case. Maybe. Yeah, I don't know. Do you know why that's the case, GetUK? I'd forgotten completely about the explicit. Does that actually close the underlying binary reader and streams though? That's what I'm worried about. Do you know? Hopefully you know the answer to that. Because I mean, closing off the client is obviously what I'm going to be doing. So, for example, what I was going to do next was this .tcp stream doesn't equal null, then this .tcp stream .dispose. This is basically what I was thinking of doing, right? If you worry about the stream state, close the stream. Close the current stream, release any resources, such as sockets and file handles associated with the current stream. So if I do this, close it, then dispose it, and then we go if this .tcp client doesn't equal null, this .tcp stream TCP client dot. We should probably go if connected. This .tcp client. Is there a disconnect? I can't remember. Probably not. I just need to dispose it, hey. Is it disposable? I'm using something like disposable list in my code for such cases. Yeah, right. Well, we can test this, right? iDisposable. That's basically what I want to do. Now we may need to revisit some of this stuff. And if we just dispose this, then we may not necessarily have to dispose of these things. But yeah. Been a while since I played with this, so it's very hard to know. Now for now we're just going to stick with a blocking style read on the socket. And we may adjust this down the track. This is effectively version 0. Should have called a wrap, call the dispose, this .dispose first and clean up. Yeah, I'm absolutely going to do that. Yeah, agreed, GetUK. I absolutely agree. Now we need to quickly do the same for HTTP transport. For now, we don't actually have to dispose of any resources. So righto. Yeah, so effectively what you're saying, Smash, is that we should do something along the lines of this. Now, this isn't what you would call the stereotypical case of disposing either, but dispose in inconvenient implementation can throw something. Yeah, yep, that's right. So what I wanted to do was just build this simple implementation, and then I'm going to go and show a reference on how you should actually implement disposable on your interface. And we will revisit this code afterwards. Now we're getting really close to the end of my 2-hour limit, which I'm surprised about. Again, the time seems to have absolutely flown. But what I just want to do is get to a point where we can go, yeah, can we basically pass down from here in this way? And once we've actually got the server with the thing, if we can wrap the client, and then we just run at this point. So this is a pretty awful hack, but it kind of makes sense because we do need to reuse the transport that we currently have active. But the good thing is that it's pretty much, oh, actually, for TCP and for named pipes down the track, we will need to have another overload, but that's not that big a deal. But for the most part, this is effectively how it should all just work. Okay, so we're just going to do, what are we going to do? But remember that in running this, we didn't actually know what the length of the metserve DLL is. We didn't have a way of skipping it because this metserve size reads everything off the wire, which, you know, as a result, isn't that fantastic? But it is what it is. Now, here's one interesting thing about taking this approach, is that if we have this using wrapped around this and then we dispose of it sort of under the hood, what happens when it tries to dispose of it again? So it should be smart enough to handle all of that sort of stuff. But anyway, we don't currently have the means to pass in information that says, you know, don't go any further than this in the byte stream that we're reading. But what we do want to be able to do at this point is we want to be able to get a packet off the wire. So for every transport, we want to be able to go get packet. Okay. Which means our TCP transport needs to implement it. Lovely, get packet. I'm just going to leave it like that actually for now. And HTTP transport needs to be the same. Okay. So then at the top level, inside our server, we're at this point where we should be able to go var packet equals this.current transport.get packet. So that is actually pulling the packet off the wire. Can we assume that the transports list always starts with the TCP transport? No, we can't. Which is why here we're basically saying if it isn't one, then we don't try and wrap. We just go and use whatever it is that we've been told. The difference is that in the stager, so the stuff that's happening in this code here, this is me pretending to be a stager. The stager knows that it's connecting to a TCP listener, and therefore the first transport that is configured will be a TCP transport. It matches that which you're connecting to. So it can kind of assume that when we first connect and we've read our stage and we've loaded metserve, that we can pass in a reference to the TCP socket. And we have to kind of do it in this way because unfortunately we are unable to reference transports as a strong type at this level because metserve hasn't been loaded. There's one other thing that we need to do just quickly, and that's this. So, parts. In fact, we should probably do this when we specify the configuration, right? So equals now in this particular case we also have to handle both bind and reverse transports, and at the moment we're just going to assume reverse, but we will implement bind at a later date. So config.url, oh actually you know what we should do? This dot, we should create a new URI, var URI equals new URI, and give it config.url. And then, pardon me, in fact, you know what we should do? Is probably bake that into the transport config itself. Assuming that this works. Public URI get private set. We'll just leave it as a public set for now, and we'll come back and address this later. So this .uri equals new URI, and give it this .url. Now, what I'd need to be able to do here is make sure that when this runs, this song is banger. It's one of the ones that comes in the Rocket League pack as well. Let me just do the configuration test. So clear this out. Go back to the configuration. Once we've done this little bit of work, we're going to have to stop, or I'll get in trouble because I promised that I wouldn't go any longer. Now I know this will behave because this URL is a HTTP URL. URL is HTTP, so when you break it up, the URI has all of these bits and pieces in it. Scheme, port, etc. Now if we come back here, let's go back to our program and remove the call to run, because I don't want to do that. Saxophone. Okay, here we go. This .url is TCP. So let's see what this does. Is it going to barf? No. Oh, awesome. How cool is that? So that means that we can use it to pull apart and get the port and all that sort of stuff. So that means that when we do our TCP transport at this point, we can literally go this config.uri.host, which is just the host component, this.config.uri.port, and that'll split the two out for us. And there we go. So, okay, so what have we achieved? We've expanded our transport configuration capabilities. We've started working on our dispatch loop. We have the ability to pass TCP sockets down to the first transport that's currently active so that we can reuse it. We've started working on the disposable functionality for the transports, which we will have to revisit down the track. But we're at the point where hopefully soon we'll be able to start reading packets off the wire. But we are probably going to have to start diving into Metasploit land very soon and creating a, reverse TCP version that talks to .NET. Any questions? Is it just me, or do these 2-hour sessions seem to disappear so quickly? Did you look at the donut.NET assembly, the shellcode? Yeah, mate, I did. I'm aware of the techniques that they're using. There's so many different ways of doing it, and they've basically gathered up all of the ways to effectively spin up a CLR behind the scenes and give you the ability to select a method for spinning up a CLR instance and invoking your .NET assembly on the fly. So it's pretty cool. It's really handy to have yet another tool out there that will allow you to do that. So is that going to be useful here? Yes and no. So to begin with, it will be useful when we get to a point where we're looking to support something like a migration. Okay, because pretty much we're already running right now. We're already running, and the CLR is already spun up. We just need to load our assemblies. So that's the beauty of the area that we're working in. We can assume at this point that a CLR instance is running. When it comes time to getting into the more complex stuff like migrating to another process, then that's when that will start to become more valuable. But again, there are so many different ways of spinning up a CLR instance in a remote process. So we may well use that donut project as a reference, and obviously if we use any of the stuff that they've got going on in there, we will certainly give kudos and attribution to the original authors of those pieces of code. That may also become useful as part of, I don't know, stages, depending on what it is that we want to do with stages. But for now, we'll be focusing on the fact that we are already running in the CLR, so we don't need to worry about that. Thanks, guys. It's been good. I'm going to have the weekend off again. Sunday is Mother's Day, so I won't be streaming on Mother's Day. So my timetable at this point will probably remain the same, and I'll focus on doing Monday, Wednesday, Friday from this point on, and giving myself a bit of a break over the weekends. But I'm super grateful for everyone hanging out. I'm definitely going to get Scape to come in and do an interview with us, so that's coming up soon. Get your questions together, jump on Discord, and let's get some bits and pieces written down so that when I do get to speak to him live on stream at a very obscure hour of the day, then we won't be wasting his time with nonsense. We can say, right, here are the key questions that we really love to learn about. So that's coming up, hopefully in a couple of weeks. Yeah. So yeah, how cool is that? It's going to be really cool. Looking forward to speaking to Scape. Just so you know, at the end of this month, I'm heading over to Austin for the Metasploit Hackathon for a week. So that time that I'm away, I might try and do a cheeky stream from over there with a bunch of the Metasploit guys. We might all sort of get on camera and have a bit of a chat. We won't be doing the CLR coding related stuff, but I think it might be cool to given that we'll have a bunch of us in a room, that we could have a good conversation, and we could probably stream that, and maybe not include it as part of this series, but you guys might still find it interesting to listen to. So with that, I'm going to save all the things, and I'm going to switch off and wish you guys a very good night. But as I always say, I'm very grateful that you're all continuing to ride the wave with me, and hopefully you're learning. And thanks to everyone who's chimed in with really interesting questions and thoughts, and thanks to the new subs, and thanks to the new followers. Without having an audience, this kind of makes this pretty useless. So seem to be averaging around 30 faces for every stream, which is actually really good. I'm stoked. I was hoping that we were going to hit double figures, and we know we're continually hitting 30. First stream that we did was around 70 people, which is kind of cool. So I am going to mix up time frames soon so that we end up covering mornings and evenings for the Americans and for the people in the UK, so everyone can join in. But for now, at least until the end of this month, I'll continue with the Monday, Wednesday, Friday schedule at 8 o'clock AEST. So much love to you all. Peace, and enjoy your weekends. Hug your wives, mothers, etc. Look after yourselves. Be good. Take it easy. Until next time.